Hello friends, another question which was came in previous IIT is the total number of possible stereoisomers of dimethyl cyclopentane. We are asked to identify the total possible ways of adjustment of dimethyl cyclopentane is of how many ways. This is cyclopentane, as they said, this is cyclopentane and it is consisting two methyls, that is dimethyl cyclopentane. Two can be present at one place. Now we will write these two at different places. That is, this is one methyl we will write, this is one methyl we will write. Similarly, we can write this one in another way, that is one is cis followed by another one is trans, one is dark, second one is what? Dotted we can write. If I go for 1 and 3 positions also, this is first position dark, third position is also dark, whereas in this case this is once again dark followed by what? This is also dark. In this way we can write. Out of this, it doesn't have any kind of chiral center, hence it is one way of representation, and it is having plane of symmetry. If I take a plane like this, it maintains what? Symmetry. Due to this symmetry, it is also adjusting optically inactive, as being it is optically inactive, it is present in only one way. Whereas if I go for this 1, 2 trans, it doesn't have any kind of symmetry. It is asymmetric. Asymmetric implies it is having enantiomers combination 1 and 2. Both are present. Hence it is what? Two structures combination. Here also it is associated with plane of symmetry. Might you are looking that plane. Here this is the plane. It maintains symmetry. This methyl CH2 followed by this CH followed by methyl and connected all things. This plane goes through the mid of this one. So therefore from this mid, this and this, this and this, and this is also present exactly on the plane. Hence it maintains symmetry. So it is optically inactive. Only one structure is possible. Whereas this case there is no symmetry, hence it is also present in the form of what? Enantiomers, that is E3 and E4. So it is combination of another two structures. So the total possible ways of adjustment of this one can be given by 1 with respect to dimethyl, 1 with respect to 1, 2 cis, another 2 with respect to 1, 2 trans, and 1 with respect to 1, 3 cis, and 2 with respect to 1, 3 trans. Total are 1 plus 2, 2, 2 plus 2, 4, 4 plus 1, 5, 5 plus 2, 7 different ways we can write. 7 different ways we can write. As far the question is concerned, there is some limitation in this question. That limitation is present like this. Here we are not asked to calculate total isomers. We are asked to calculate exclusively the stereoisomers. Stereoisomers maintains the same connectivities, hence this one and the remaining all are no way connected with the same number of connectivities, hence this particular one is an isomer, but this isomer is not the stereoisomer. This will becomes the structural isomer. So therefore out of this possible 7, if this one is eliminated or subtracted or removed, the total number of possible stereoisomers of dimethyl cyclopentane can be given by here 1 followed by its analog is having 2, here 1 followed by its analog is having 2. So therefore 3 plus 3, total 6 stereoisomers are possible. How many are possible here? 6 stereoisomers are possible. And another question is framed to identify the type of isomerism possible with a given molecular formula, and the formula is given by C3H6O. A compound with the molecular formula C3H6O can show which type of isomerism, and the corresponding options are associated with, and options are provided for us are consisting of, one is positional isomerism, second one is positional followed by metamerism, next one is metamerism, and the next one is functional group isomerism. These are expected to be present as the molecular formula of C3H6O is concerned. Suppose if I keep this O for some time away, then this will belongs to the alkene formula. Alkene stands for double bond equivalence is found to be double bond equivalence. Generally, if I calculate the double bond equivalence, DBE, double bond equivalence can be given by carbon plus 1 plus nitrogens minus hydrogens. Carbon plus 1 implies 3 plus 1 plus nitrogens 0 minus hydrogens by 2. This is 4 minus 3 is equal to what? 1. One double bond equivalence is there. By maintaining 1 as double bond, if I write this particular compound, this may become CH3, CH2 followed by C double bond OH. In another form, if I want to write by maintaining 1 double bond, what I can write? I can keep that C double bond O interior. That will become CO followed by CH3. These two are said to be what? Functional group isomers. One is aldehyde functional group. Second one is keto functional group. Hence, these both two becomes one to other as functional isomers. Here, whatever the formula was provided with that, whatever structures that we got by chance, we can't claim them as positional isomers because functional group is varying. You can't claim as metamers because one time and other side groups are so not varies in the alkyl system. Metamerism is not claimed, positional isomerism is not claimed, hence it is better to say them as what? Just functional isomers.